into the space. Okay, so what is basically first I just tell about what is RDD, just a very basic information about the RDD. So RDD is a resilient distributed data set. So what is the meaning of resilient? Resilient means here the fault tolerance. Why it is called the fault tolerance here? Because sometimes like when you are doing some operation and your operation is got failed, so you want to recompute your operation and generate the result. So it is because of that, because whenever any time the operation got failed, it will recompute and got the result back. So that is the reason it is called the. And it is an immutable collection because whenever you are doing any operation on a RDD, it will create another new RDD. Why the reason is immutable? Because you can't change in the existing RDD. You will be doing some operation and create a new RDD. So the benefit is every state, every operation result you are storing is a DAG. There is a direct acyclic graph is there that you can maintain and you can store in a linear graph. So whatever operation you are doing, keeping it in a DAG. So that is the benefit of because of it is a resilient. So any point of time, anytime any operation failed, then you can recompute and generate the result. So that is the purpose of the resilient. Distributed is because it can be shared the data across the nodes. That is the reason it is distributed. And different types of data set it can handle. It can read the JSON file, CSV file, text file, or data from the RDMS, data from the NoSQL, data from the Elasticsearch. From anywhere it can take the data. So multiple data sources support is provided. Okay. So and RDD can be also cache. What is the cache? So like if I want to store the data in memory, so it will be more faster because when I'm storing the data in memory, so it will not take that much time to read the data from the disk. So rather than storing the data in the disk, it will be using cache. And the advantage of using cache means it will be more faster. So whatever program we are executing through RDD in Spark, that will be faster than the MapReduce program. Okay, but sometimes I have to use persist method to store the data on the disk. Suppose my memory capacity is some amount of memory is there, but my data is more than the memory. So how will manage it? In that case, the whatever data is processed, that will be put in the cache, and once the data is processed, the whatever data is in the disk, that will be moved to the cache. So that way it will be, yeah, here it is written, if there is not enough RAM. So persist is used for when it is partially stored in the disk, but it will be whatever the size of the memory it will be there, it will use and then it will read the data again. So that way it is that way it is using the persist method. Okay. And now I'm just going to talk about these are the RDD features. So what are the features of RDD is there? So RDD is having a lazy evolution is there, immutability there. I told the RDD is immutable. We can't change the RDD. We can create a new RDD, but existing RDD we can't change. And fault tolerant, I already told about this. So it is basically DAG is maintained, and any point of time any operation got failed, it can be complete. Persistence, so it can manage the data on the disk also, and RDD can be partitions. So what is the need of partitioning? So suppose I have some data, but I want partition the data into multiple partition so that my program will be going faster. Okay, so there are the different methods are there for partitioning, like coalesce and repartition. I'll tell about those partition methods, so we can use that. And the location and strictness, cross-chain operations, and in-memory computation. This is the biggest feature of the Spark RDD. It is doing computation in the memory only. So whenever it is doing the computation in memory, that is the reason it is very fast, because it is not reading the data from the disk. But sometimes whenever it is reading data from the disk and doing the computation in memory, then it is 100 times faster, 10 times faster. But when it is doing the computation in memory, then it is 100 times faster. Okay, so Spark RDD, this is Spark provides both the way in-memory computation and disk computation, like disk and memory computation. Okay. So what are the transformations and actions are there? So basically, what is the need of the transformations? Like suppose if I get a data, suppose I get a data from some CSV file, and this data I created a data frame or RDD data frame. I got it. Now I'm doing some operation on this. I'm doing some operation. What kind of operations I can do? Map, flat map, filter. So whatever operation we can do RDD, the same operation we can do the data frame. The only difference is, like data frame, we are applying the operation on a columns. So in data frame, we have data in a columnar format, row column format. Okay, so that is the data in the row column format, and we can apply these transformation on columns. Okay, but RDD is a semi-structured data, right? It is basically like once we get the RDD, we have to iterate the RDD and get the columns, and then we apply transformation. So that way we work on the RDD. So what are the transformations and actions are there? So transformations, basically when we apply a transformation, so it will create a new RDD. Okay, but action is the final result. That is the main difference between the transformation and action. So transformation, like if I say map, flat map, filter, these are the transformation. But suppose if I say I have to finally count the number of record. So count the number of record, this is the action. So count is the action. Count by value is the action. Count by value. Okay, collect is the action, because I will get the final result by collect. But filter, flat map, these are the transformation. So this is the basic difference between the transformation and action. So transformation, when we apply a transformation, we get another RDD. So transformation is not an end result, but action is always end result. Okay. So transformation, there are the two types of transformations are there. We call it like narrow transformations and wide transformation. So if I say I have how many transformations are there? Map is there, flat map is there, we have a joins are there, filter is there. So narrow transformation means all the elements that are required to compute record in a single partition, live in a single partition of the parent RDD. So basically here is data is coming from the single partition. Like if I am applying the map, flat map, map partition, filter, So I am taking the data from the one partition and again storing into the another partition. So data is not coming from the different partitions in RDT. So that is the main difference. These are called the narrow transformation. What are the wide transformation? When the data is coming from the different partition of the RDT, like group by key, reduce by key, join, these are the wide transformation. Here is, if I take one RDT, I apply map, I get another RDT. Okay, but that data which is coming in the RDT, that is coming from one partition. Here is data is coming from multiple partitions. Okay, so like one operation we are doing, like this group by key or reduce by key, it is taking the data from the multiple partition. So here shuffling is there. Here is no shuffling, but shuffling is here. Okay, suppose I have to aggregate the data based on the key, I will use group by key or reduce by key. Okay, so group by key, what it will do? It will aggregate the data based on the key. So whatever keys are there, if it is the same key is on the different machine, it will be aggregated to the same machine. So shuffling is required. I will tell you what is the difference between the group by and reduce by key. So group by key aggregation, first it does the aggregation, then shuffling in case of reduce by key. But in case of group by key, it does the shuffling after the aggregation. That is the main difference. Okay, so reduce by key having a better performance. Why? Suppose I have suppose I am using group, okay, and I am getting two partitions. One partition having some values, some keys say A, B, comma C. These are the three keys are there. Okay. In another partition we have the data A and C, D, E. Okay. Now if I'm combining, if I'm just aggregating the data of these two, so basically A is 2 times is there. So it will be, in case of group by key, it will do the shuffling after, like once the data is moved to here, A comma A, and then B comma C, B only one time, and then C comma C, D, and then E. And then the final result will be 2A, B, 2C, D, and E. But in case of reduce by key, suppose I have a A is there, B is there, and E is also there, okay, again, and C is there. So it will do the aggregation first. A to A, B, comma C. So like this, it will do the aggregation first. So that is the main advantage. But here is aggregation happening after the, okay. So reduce by key, like less data will be transferred over the network. Here, like we have seen map combiner. Combiner concept is seen in the map reduce combiner. So combiner does the same thing that is done by the reduce by key. Combiner does same thing as reduce by key. Okay, and group by key as without combiner. So that is the way to understand what is group by, but both are the wide transformation because both are taking the data from the different partitions. That is the reason it is called the wide transformation. So that is the one difference basically where we should use transformation. So when I want to have a data from the different partition, I should go for the wide transformation. Okay, and then I want to, but these transformations are not a replacement of the wide transformation. So only the thing is, whenever I want the particular type of transformation, then I will use it. Suppose my requirement is a map, so I will use map. If my requirement is a flat map, then I will use flat map. But suppose my requirement is a join, so I have to use a wide transformation join. Okay, so there are different types of the joins are there. We can use those joins. Okay, so first we look at what is map. So map is basically it is iterating the RDD, iterating RDDs each line, and it will be apply the operation on the each element of the RDD. Very simple example is suppose my RDD is having the 5 element and I want to apply the x plus 2. So what will be my final result is whatever element is there in this RDD, it will be addition of 2 and then I will get the result. So you can see here, suppose in my RDD there are the 5 elements, I will get in my output also the 5 element. So that is the map is always giving a same number of element in the RDD. Okay. Another example we can see, like I am reading some text file and I am just applying each element of the file, like as a line. I am taking each line in my text file and each line comma line dot length. So what I am doing here, I am just printing line with the length. Okay, so how the result will be there? I will be printing line with the length. Okay, so basically what I am doing is here map is for each line is a one element and I am calculating the length of the line. Okay, length of the characters, total number of characters in that line. So that I want to print. So I have to iterate and I have to print it. Okay, so I can do this. So this is the program. You can see here. Actually, this one will not run. This is a SVT one. I just copy it to Maven one. This is a Maven one. So here I'm iterating the RDD, right? And each element I'm iterating it. So I'm applying the map function here. Okay. If I'm using a data frame, I can directly apply the map function on the column. Okay. So because data frame is a representation of the tabular form. But here I have to iterate each element of the RDD. So what output is coming? You can see the line and length because I have used like this, line and length. If I want to show only length, like this, I have created pair RDD. From this RDD, I have created pair RDD. It's a pair RDD. So only length is coming. The first line is having the length. Second line is having the length. So if we see this input file, 15 length, this is 19th length, right? So that length I am showing. So how many elements are coming in output RDD? Only 2, because number of elements in input RDD 2. So same number of elements are coming in the output RDD. Okay, I think hope so this is clear. Okay, so next operation is a flat map. Okay, in our word count program we see the flat map, right? So in the word count program we see the flat map. There we were doing the splitting with the space and counting the word. Okay. So flat map is basically a function to each element of input RDD, and it will generate the more than number of element. Okay, that is flat map. Suppose if I say example, I am reading a line and the line is having one single line as an input element, and how many characters will be generated, how many words will be generated. If I am splitting with the flat map with the space, so I will get the number of more than number of words. So suppose one line is having 10 words, another line is having 15 words, or third line is having 2 words. So total number of words will be 10, 15 and 2. So total number of words will be more than the number of input element. So input element is 3 lines, but output number of words, how many are coming? Those are coming 10, 15 and 2. That is 25, 27 words are coming. So that is called basically the flat map. So flat map generates the more than the number of output element. But in case of map, returns only one element. Per input element, it is returning only one output element. But in case of flat map, it will return the list of the element. For each line as an input element, it will generate the list of element. Okay. So here I am applying the map first, and I am doing the split with the space. Then I am applying the flat map. So if I see in this example, just simply I have to change the flat map. So here is what is the difference. So I'm giving a space as a separator. So I will comment this line. I will comment this line. So only difference is here I'm taking line and I'm doing the each element. I'm just collecting the data. But here I'm splitting with the inside the flat map. I'm calling the split function, and this split function will be giving me the more element. And flat map will be doing flattening. So main purpose of the flat map is how many elements are coming. Suppose there are the 3 lines are there, and each line is having a different words. So it will do flatten. It will combine. It will collect all the words from each line, and then it will return to the flat map. Okay. This is one, two, three, four, 5, 6, 7, 8, 9, 10. So total number of elements are 10. So flat map is giving, okay, I think this space should give. it is doing flattening on the character. It is not considering the space. So you can see here, you are getting total number of words. So how many words you are getting? 10. If you want to count function you can call. You can call the action. Okay, suppose I want to do the count. Dot count. And you can print the count. So this is action. So you can run it. Yeah, here is total number of words, count is coming 10. Okay. So this is our flat map. Next one is filter. Why we need filter? Suppose I have some RDD, but I want to filter out from that RDD and create a new RDD with the filtered element. Just one example is there. I have some 5 natural number is there, but I want to check how many even number is there. So which element I want to filter out? I want to filter the odd number. I want only even number. So 1, 3, 5 will be filtered and I will get final result as even number. So that is my filter function. So basically what I need to do, suppose if I say in my text of lines I want to apply filter, I say if value is spark, like some word is a spark, I want only those words. That filter I want to do. Okay. So what I can do here, where I am doing the flat map, here I will apply the filter and I say I should check the word hello. Okay, now I see how many words come. So here I am passing an expression. This is an expression, condition expression. So through condition expression, so hello word it is filtered out. If I don't want equal the hello, which word, those word I want. So here is lambda function we are using, lambda operator. So here we are taking see any hello word is not there because I have filtered out. Okay. So both the ways, like if I want, I can use equal, double equal, or if I don't want those words, so I can use not equal. So this is basically filter. So I can use after the flat map, whatever output is coming from this RDD, it will be applying filter and get the new RDD in the flat map file. So this kind of thing is called inline function, right? Basically you are applying one operation here, the another operation you are applying on this. So this is one transformation, this is another transformation, and finally on this you can call the action. So now in this one, only count will come. Okay, this count will come and this count we can print it here in the next line. So multiple operations we can do in a single line. So now in this flat map file, this RDD will get count. So total 9 is coming because 1 is filtered out. So how many words without hello? Those are 9. Okay, so I am getting the result 9. Okay, and another transformation is there. Okay, narrow transformation. map partitions, and map partition is a broad transformation because it is taking the data from the different partitions. Okay, so basically, map partition is convert the each partition of the source RDD, and basically it will do the parallel processing. Okay, so basically when we are applying the map partition and map partition with index, these are two for the performance. Like generally we use these two transformations basically used for the when I want to like the performance I want to make it good, then I can use these two transformation. Union is basically I have a two data set. This is broad transformation, and I want to combine the two data set into single data set. That is called the union. Okay, so union is combining the two data. It's very simple example. I have this one data set. This is the second RDD, and this is the third RDD. And I am just doing RDD1 dot union RDD2 union RDD3, and finally I will be getting the result. Okay, so I will get how many elements in the output RDD? 1, 2, 3, 4, 5, 6, 7. So total 7 elements will be there in this RDD union RDD. Okay, so that I can. Okay, so this double code things now come. One. We can do st.parallelize, or otherwise now I just create a very simple RDD. This is one RDD, another RDD, RDD2, RDD3, So I am printing each RDD. So it is the collection of the all three RDD. Okay. So another operation is intersection. Okay. Intersection is like we want to intersect, like we want to common element, we use the intersection. Okay, that you can try. So intersection is there. This side is hand. So intersection is like common element, we can get it. Distinct means if I have a duplicate element, I can call, I can get it unique element. So I can remove it will remove the duplicate. So basically I can use distinct. So I can use it here. RDD2, RDD1 dot distinct. Oh, I have given the unique element. Try it. So 1, 2, 3 we are getting. So distinct, basically we are getting the 3 element. So that is basically distinct. And group by key, it's a pair RDD. Like basically it's a wide transformation when we want to get the data from the different partitions, and it will be doing aggregation after shuffling. Okay, so that is group by key. So data is shuffled basically based on the key, but it will be once after shuffling done, then it will aggregate the data for creating a resultant RDD. So group by key, what I will be doing here, I am doing this is a group by key. I have to, the group by key will group the integer value based on the same key, but it will be aggregate the data after the shuffling. So we will get the same result whether we do group by key or reduce by key. The only difference is it is internally using the aggregation and shuffling, or shuffling with aggregation. Here aggregation is first, then shuffling, and here is shuffling first, then aggregation. So both the result will be coming same in the reduced by key and group by key. But reduced by key is the faster because aggregation done the first. Okay. So that's the reason the reduced by key is the faster. So it is doing the word count things. So it is giving each word as a one count, and then it will be aggregating the words by combining the same word. It is doing the word count. Okay. So it is not reading the words from the file. It is just creating an array. Okay. And then it is passing that array and create a RDD. And then after that it is applying the map, and each word it is giving a one count, and then it is applying the reduce by key. Then it is printing the word count. Okay, the words. I'm just doing the word count for this. Let's see. And then I'm just printing it. So I'm getting the word count. I'm getting how many words are there for 2, how many words are there for 1. So this is for the reduced by key. But performance we can see when we are having very large amount of data. If I want to apply the group by key, so whatever data I have, then I can use group by key collect. Group by key. So how to use group by key? So here I am getting a 2. This is 2 actually. I don't want to correct. This compact buffer is coming. To iterate group by key collect and then group dot for each. This one I have to use. First I have to do collect. This is already done. Data dot collect action will return all the element of a data set as an array. Key dot reduce by key is coming. Return the number of record. Okay, 2 will come. The group by key only just grouping the data. It will not do the sum. Okay, so it will be doing just grouping, like how many 1 is there, how many 2 is there, it will make it group. Okay. And sort by key, like if I want to sort the data on the based on the key, so this math, English, science, computer, so based on this, it will sort the data. That is our sort by key. Join operation, like if I want to join one RDD to another RDD, so it will make a join. We can do join between the two arrays. So we can combine it based on the key. Like here A is value 1 and A 4, B 2, B 7. So it will make a join, right? So that way it will give the result. So we can see. I am taking less data. So what does MK string do? This MK string is whatever result I am getting, I will be combining it with the comma. Like I want to concatenation of the data that I can do with the MK string. So in Scala, we have MK string for the making it string. So whatever result we are getting, we will making it a string and we are concatenating with the comma. So that way we can do. So here we are getting the result. So here join is happening. A1, A is having 1 comma 4. Data 1, data 2. Common values join. It's an inner join. So A values here 1 comma 4 and 1 comma 6. So how many values we are matching here? This is inner join. So there is a left outer, right outer. So those joins also we can perform. Okay. So tomorrow I complete this other RDD's transformation and action, like count by value, and there is a collect. So those actions I will complete. Any questions there? Yeah, thank you. Thanks. Bye.